because I really want to make sure you're good with it. Is that a function? Yes. Why? Because it passes the vertical line test, right? If I gave you this set of points, would that set of points create a function? How do I know it would create a function? There are no repeating x values. No repeating x values can't lend itself to anything that's an issue, right? Trinity, I'm gonna pick on you for 30 seconds. Ready? I want you to create or add another point to this where it would not create a function. I want to add a point where it's not going to make this a function.
3, 2.
All right, so Trinity says 3, 2. Okay, and I'm glad she actually said that. It's wrong. It's okay. Now, I'm glad she said this because this is where we have issues, right? The issue being, is it the repeating x's? Is it the repeating y's? That's what I'm not sure about. Okay, so here's the thing. Trinity, you put $1 into the vending machine, you get 10 cents back. Emily puts $2 in, gets 2 cents back, or 20 cents back. Gavin puts $3 in the vending machine, gets 20 cents back. They all put different amounts in, right? If they all put different amounts in the machine, we don't know if the machine created had a problem, do we? So what do you want to do, Trinity, to switch this so that it's going to create an issue? Change 3, 2 to be 2, 3. Exactly, right? Because in this case, somebody put this amount in and got this much change. The next person put the same amount in and got a different amount of change, right? So this would be not a function, right, because of that. Now, Trinity actually did a great job of introducing us into where we go now. What happens when I have the repeating y values? Okay, and that's what we're going to see right now. So here's what I have, Trinity. I have a function f of x. Jade, I have a function g of x. Okay, and here's what I want to do. I want to take the values of the domain, and I have the same values in each, right? -2, 0, and 2. And I want to create the range for f and g. So, Sean, if I take -2 and plug it into f, what do I get? Good. So I'm going to draw a mapping. That's one of these, right? Okay. Janine, how about if I plug in 0? 0, good. Plug in 0, 2 times 0 is? All right, I agree with that. Is it Annalise or Annalise? Annalise, that's what I thought. Annalise, if I plug in 2? I agree. Plug in 2 and I get 4. There it is, right? Quick question, guys. Is that a function? Yes, because there are no repeating what? Domain values, right? All the domain values are unique. Okay? Good. Jelani, plug in the -2 into the g. What is -2 squared? +4. All right, what is 0 squared? 0. And what is 2 squared? +4 again. Okay, good. Molly, what do you think? Is g a function? G is a function, I agree, because all of these values were what? Give me a word. Unique, different, right? All unique or different. What's different about this problem, though? Yeah, so there's, instead of the issue that we had a couple days ago where I had repeating x's leading to something that's not a function, in this particular instance, I have repeating y values. And so the question is, what does that mean, right? We know what repeating x values means. It means it's not a function. What happens when I have repeating y values, okay? Everybody understand what we're doing today now? Great. So what is fundamentally different? F of x has no repeating y values. G of x has repeating y values. Right? G of x has repeating y values. And so that's a bit of a problem. We got to figure out what that means. Wilson, you doing okay? Right? Understand what we're trying to accomplish today. What happens when we have repeating y's, right? So I'm going to give you a definition of something known as one-to-one. A one-to-one function is one that will always give you different outputs. Something is one-to-one, Blake, when there are no repeating y values. Let's write that down. A function, actually I don't want to use the word function. A relation is one-to-one when it has no repeating y values. Okay? Now, I did something a little sneaky right there, guys. It was a little sneaky. I was kind of hesitant about this word, right? I started off saying what? I started off saying a function is one-to-one. And then I changed it to be the word relation. Is everything that we've talked about today, so far this year, a function? No, right? So for example, ready? Let me show you guys something. Check that out. There's my domain. There's my range, okay? So here's my question for you guys. Ready? Is that a function? Function. Do any of the x values repeat? No. Is that one-to-one? No, because why? The y values repeat. Is that good? Okay, so this is an example of a function that is not one-to-one. Everybody okay with that? All right, now I'm going to give you another picture. Let's do this one in green. Domain, range. 3, 4. 5. Okay, ready? Y'all know what the questions are going to be. Is that green mapping a function? No, because why? 5 goes to 3 and 5 goes to 4. So this is not a function. But hang on a minute. Is it one-to-one? It is one-to-one, isn't it? Guys, when something is not a function, I can use a different word for that. Relation. All right, let's look at our other two scenarios. Our other two scenarios are these. Ready? Is it a function? Is it one-to-one? This is a one-to-one function. And our last scenario. So what does 1 map to? 1 maps to 4. What does 2 map to? 2 maps to 4 and 5. What does 3 map to? 3 maps to 6. So does any of the domain values repeat? Which one? 2. Do any of the range values repeat? Which one? 4. This is not a function, and this is not one-to-one. All right, so we see all 4 scenarios where those things can occur. Guys, that to me, that little diagram right there, those four little graphs, right? That pretty much emphasizes things that we're doing in 2 out of the, I think, 4 lessons that we've had so far. All right, so to me, this would be like something that I would really want to make sure I get and I understand and I have a good concept of. Okay, because you're seeing all the possibilities. The nice news is when you look at this mapping, and now you come down here and you look at this chart, we can now do the exact same thing, can't we? So if I look at example 1, it says, I want to know which of these is a one-to-one function, right? So one of these is a one-to-one function. So the first question is choice 1 a function? Not a function. And it's not a function because of that, right? Yeah. Also the 9s, right? So it's either the 4s or the 9s is why it's not one. Okay. Is number 2 a function? Yes. Is number 2 one-to-one? No, because of the what? Repeating y values. So this is not one-to-one. The third one, 1, 2, 3, 4 are the x's. 2, 4, 8, 16 are the y's. This is a one-to-one function. All unique. All right. And then what's wrong with the last one? The 10s, right? So this is not, oh, and this, right? So this is not a function, and it's also not one-to-one, right? So again, what are we doing? We're seeing another representation of what we just did on the previous thing, right? Doing good? Actually, that's probably bad English. Doing well? That's better, right? Good, thank you. What's wrong with doing good? Anybody know? It doesn't sound that good. Are you doing good? Are you doing well? I don't get it. Like, isn't it the same thing? How'd you do on the test? I did good. How'd you do on the test? I did well. I mean, we all get it, right? Whatever. If you're considering the following graphs, which of the following are functions? Is number 1 a function? Absolutely, because it passes the. Okay, so this is a function. Is number 2 a function? No, so this is not a function. Is 3 a function? Not a function. Last one is a function because it passes the vertical line test. All right. So it says in part A, it said circle the two graphs above that are functions. Okay, so this is a function and this one is a function. Explain how you know they are functions. They pass the VLT. Of the two graphs that you circled, which is 1 to 1? Sadie says? Sadie says 4. I agree. Now explain. Okay. I know precisely what you mean, and you definitely get it. Your explanation is terrible. And this is the hard part about it. I know you know what you're saying, and that made total sense to me. But the problem is when you write that down on a piece of paper, it's not very articulate. You want to try again? What she said, I want to repeat it because I don't know if everybody heard it. She said in the first one, 2 points are at the same value or something like that, I think you said, right? Something along those lines, right? So go ahead, you want to try again? In the first example, okay, good. Two points have the same y value. That to me is much, much better, right? So in other words, that's a root, isn't it? So what's the y value? 0. So maybe this is -5, 0. And what's this right here? That's also a root, isn't it? And so maybe this is what? Maybe this is 1, 0. So what can we say? That is two y values that are repeating, right? Which means it can't be 1 to 1. Okay? And I like that explanation a lot better. Can we explain, so we can explain why something is not 1 to 1, so can we explain why something is 1 to 1? Yeah. Yep. Yeah, you could. And it is, well, linear line. Here's the, not all lines, I'm going to blow your mind here. Okay, ready? Not all lines are 1 to 1. Okay, ready? Hang on a minute. Because right now she's like, hey, is this line 1 to 1? Because all the y values are different, right? Is this line 1 to 1? Because all the y values are different, right? Is this line 1 to 1? Yeah, because all the y values are different, right? Is this line 1 to 1? All the y values are the same. So a horizontal line is not 1 to 1, is it? Okay. A horizontal line is not 1 to 1. Geez, I wonder if that concept could be applied to test. Oh, what about something called a horizontal line test? Because guys, if a vertical line test determines if something is a function or not, then a horizontal line test would determine if something is not 1 to 1. True? Right? Because do you agree that this horizontal line has all the same y values? So if this goes through a function in more than one spot, then the y values must be the same, and so it can't be 1 to 1. Is that okay? That concept seem all right? So what makes something a 1 to 1 function? It passes the vertical and the horizontal. Okay, good. So there's your concept, right? And Sadie did a great job of explaining it. So she said the first one is not a function. I'm sorry, is not 1 to 1 because two y values exist. Two of the same y values exist. And the last one is 1 to 1 because none of the y values repeat. Trinity has a question. Yes. It's exactly right. 3 would not be a function, nor would it be 1 to 1. How about 2? It would be 1 to 1, wouldn't it? It would pass the horizontal line test, but it's not a function. Okay, we got the idea there. So, which of the following graphs is 1 to 1? Is it? Which of the following is 1 to 1? Now, okay, so I'm not hearing anybody say 2. And why not? Because of the horizontal line test. Does it pass it? No, it fails, right? So this is not 1 to 1. And I didn't hear anybody say 4, so this is not 1 to 1. So there was some confusion about whether it's 1 or 3. It has to be, Emily says it has to be a 1 to 1 function. Ah, that little word in there, function, right? So it has to pass both the HLT and the VLT. It's got to pass them both. This one does not pass this one. This is a 1 to 1 function. Yes, Sadie? You good? Any problems there? And our last question of the day. The distance that a number lies from 5 on a one-dimensional number line is given by the function d of x equals the absolute value of x minus 5, shown by an example or by a graph that d of x is not a 1 to 1 function. All right, fair enough. If I asked you guys to graph this thing, and you didn't have a calculator, okay? Didn't have a calculator. What's a way you can graph it? Give me something. Don't have a calculator. What are you going to do? Cry, fetal position, what? How can I graph something if I don't have a calculator? Find a y. Okay, great. So we want to find a y-intercept to start. Jameson says, let's get ourselves a y-intercept. How do you get a y-intercept? Plug in 0. So here's Jameson's idea. We want a y-intercept, right? So he says plug in 0. So plug in 0 and we get the absolute value of -5. Absolute value of -5 is 5. Okay, so this is a point on our graph. Okay, that's 1 point. Great. Now what? How do I get my graph? Say again? It's 1x. What's that mean? Oh, okay, so you're thinking line. All right, I actually, so here's the thing. I'm going to show you guys something pretty neat. What does an absolute value do? Take something that is negative and makes it positive. If something was positive, does it do anything to it at all? No. Don't write this down. Ready? If these absolute value signs were not here, I would have that, right? Isn't that the equation of a line? To graph a line, I first graph the y-intercept, which is down here, and then I graph additional points by utilizing the slope. And the slope in this case is the number prior to the x or 1. So if I have a slope of 1, what does that mean? I rise 1 and I go to the right one. So I rise 1, I go to the right one, and I rise 1, I go to the right one, and I rise 1, I go to the right one, and I rise 1, I go to the right one, and I rise 1, I go to the right one, and I wind up here. Does everybody agree that this would be the line x minus 5? Okay. As soon as I put these things on it, what happens? Well, anything that was negative becomes positive. So what's going to get moved? All of that stuff. Isn't all that stuff negative? So what am I going to do? I'm going to take those values and make them positive, which means this -5 becomes +5, this point up here, right? And my graph is going to bounce up like that. So this green is my graph. Now, of course, you got a graphing calculator, so that concept right there doesn't necessarily have to be remembered, but it's an easy way to think about it. Graph the line and then take the negative stuff and reflect it. Hey guys, is this 1 to 1? This is not 1-to-1 because it does not pass the HLT.